Okay, so the last day we introduced logs in our log tables, page 21, mainly recognising when we have indices, how we can kind of get them into a quadratic. It comes up a lot. We can almost expect to form a quadratic where we have an unknown in an indice or in an index, and then we can sub in for that as something like y, solve the quadratic, and then get our final answer. The only reason why this one was slightly different was because they wanted it in the form m equals log with a base 3 of p minus q. So we had a little bit of work to do at the end there. So we did that in our last video. We're going to look at continuing some of our log rules today. So we want to get to this exam question here where we're really familiar with some of our log rules. It's actually quite a nice question, but just so that we get used to some of our log rules, let's have a look here at some questions. So if you've started logs, it would be worth pausing the video now and trying a couple of these. Okay, the first question says y equals 2 to the power of x minus 1 plus 3, and it wants us to rearrange it so that we get x in terms of y. Okay, so the first thing, kind of similar to surds here, if I'm trying to get something on a side by itself, okay, and there's stuff in powers in the index, okay, similar to surds, the way you want the square root to be on a side by itself or the power of a half to be on a side by itself. Here, because we have an x in a power, it would be ideal for this term to be on a side by itself. Okay, so before I start trying to do stuff with the powers, I'm going to work towards getting x on a side by itself by just recognising that I can minus 3 from both sides. Okay, so all I need to do is minus 3 there to get towards x being on a side by itself, but that does mean that I have to minus 3 from that other side there. So that I will get y minus 3 is 2 to the power of x minus 1. Okay, now there are a few ways we can go through this, but I know how to, if I have an unknown in my power, I know how to use my log rule to get that on a side by itself. Okay, so that's what we done in the last video as well. If we have a quick think back to our log rule, it's that if I have a to the power of x equal to y, okay, if that's true, then log with a base a of y is equal to x. Okay, and this isn't just a one-way arrow. So also if this is true, then this is true. So it actually works the opposite way as well. Okay, so here I can manage to actually get this thing that's in the power out of the power if I follow this rule. Okay, so it will be my log, and then what would have been the base underneath the power is now the base on the log. So here it's a base 2. Okay, what it all was equal to before is now the big number after the log. So that would be y minus 3. Okay, and that's all equal to x minus 1. So I didn't really give myself enough space here. If I can just kind of drag that over here. Okay, if I rewrite that whole thing, okay, and the only thing that I still need to do to get x on a side by itself is get rid of the 1 that's subtracting, so that I get log the base 2 of y minus 3 plus 1 is equal to x. Okay. This one here, show that log with a base 25 of x is equal to a half of log 5x. So again here, if you didn't get that one, if you didn't get the one above, firstly, if you want to try this one now, you can. Okay, I'm actually going to just rearrange this page a little bit so that it's not as messy. Okay, so that we have a little bit more space. Okay, so show that here for part 2, okay, show that log with a base 25 of x is a half with a base 5 of x. Okay, so for this one, we're going to have to use our change of base rule. Okay, we had a base 25, they somehow want us to get to a base 5. So we need to look at, well, what is my rule to change a base? Now remember, if we're asked to show something, okay, the best way to do this to make sure that we get our marks is to just start and pretend that you don't have the answer. So log with a base 25 of x. Pretend you don't have the answer. So you have not got this yet. Okay, but we know that we need to work towards a base of 5. So I'm going to start with this, and other than the fact that I know that I'm getting towards a base 5, I'm not doing anything with this. Okay, so I know I need to change the base, so I'm going to go back to my log tables and see where is there something where the base changes in my log rules. Okay, so here, base is the same, base is the same. Okay, this one, yeah, it completely disappears. Log with a base A, log with a base A, so they all have the same bases. This one here is the only one where they change. Okay, so let's go up to where our question was. Okay, and let's write in our rule. So it's that if I have log with a base B of x, okay, that is the same as log with any base, so A, of the bigger number, so x, and then log with that same new base A of the smaller, what used to be the base, so B. Okay, so I can rewrite this with my new base so that I have that it is equal to log with a base 5 of what was the big number, so x, all over log with a base 5 of 25. Okay, now if I do that, okay, can I simplify the top line? So log base 5 of x, no, can't simplify it because it has an x in it. Okay, so that's just going to be log with my base 5 of x over, and then log with a base 5 of 25. Can I solve that? Yeah. Okay, I can put it into my calculator, or I can know that it's asking me 5 to the power of what gives me 25? Well, it's 2. Okay, so I have log with a base 5 of x over 2, which I could leave my answer as, except for the fact that they've asked me to show that it gets to this, so I'm just going to write it in that same form. Okay, if it's divided by 2, that is half of my log with a base 5 of x. Okay, the next one then, okay, it wants us to solve for x when they gave me that log with a base 2 of x minus 2 plus log with a base 2 of x is equal to 3. Okay, so there is a couple ways I can do this. So it is, again, depending on what way you see first. Very similar to the way we do our log rules or our indice rules, where we might all end up seeing different ways of doing it, but we'll get the same answer in the end. Okay, and it was the same over here and up here actually. Okay, so over here, if I was looking at that and I have my log rules open in front of me, okay, I would see that, well, I have the same base and two different big numbers and they are adding together. Okay, I know that that is equal to the bigger numbers multiplied together. Okay, so if I look at my log rules, okay, my very first log rule is that if I have log with a base a of xy, that is equal to log with a base a of x plus log with a base a of y. So with that in mind, okay, I can actually merge that left hand side together. Sorry, I forgot how big that rubber was. Okay, I can actually merge that left hand side together so that I get log with a base 2 of, but I need to multiply, those are the brackets, the x minus 2 needs to multiply by the x. Okay, really handy for me to merge them together because now I only have one log. I can go back to using my log rule here. So I'll actually be able to get rid of the fact that there's logs in this question. Okay, so let's go through this anyway and write it out with that multiplied so that it's nice and clear. Okay, that I'm going to have x squared minus 2x is equal to 3. So if you were asked to get rid of the fact that there is a log here, okay, you could use your log rule, which is what we're going to do. Okay, and it tells me that a to the power of x is y if and only if log with a base a of y is equal to x. So that means that if I want to get rid of this log, I'm going to go backwards in this situation. So it's going to be a, which is 2. Okay, so 2 to the power of what the whole thing when it was a log was equal to. So here the power is going to be 3 is equal to x squared minus 2x. Okay. If you didn't get that far, take it down now and pause and reflect. Okay, what do you have here? What can you do? Okay, what do you have here? What can you do? Okay, can you get on to the next step? Yes, we know what 2 to the power 3 is. 2 by 2 by 2, so 8. Okay, we have now gotten on to the next step. Pause and look, can you solve this somehow? Yes. Okay, it is a quadratic. We know to solve a quadratic, it has to be equal to 0. So I'm going to subtract 8. Okay, 8 didn't have a like term, so it's just going to be subtracting from 0. So it's just 8. Okay, and now that's what 0 is. 0 is equal to all that. Okay, if you want to make it look like your quadratic that you're used to seeing, you can write the equal 0 on the other side either. Okay, so now you just have a normal quadratic that's really quick to factorize. Okay, you are looking for two numbers that multiply to give you minus 8 and add to give you minus 2. So we're going to put x first in both, and then I'm going to use minus 4 and plus 2. Okay, so if I do that, then I'll have that x minus 4 could be 0, in which case x is 4. Or my other option is that plus 2 is 0, in which case x is minus 2. Okay, have a quick look back and check that both your answers are valid. Okay, so if I sub in here 4, okay, I would have log with a base 2 of 4 minus 2. So log with a base 2 of 2. So 2 to the power of what would give me 2. Okay, so let me quickly do this out just so I can make it really clear. Okay, let's check both of these. So here I would have log with a base 2 of 4 minus 2 plus log with a base 2 of 4, okay, is equal to 3 if I want to double check it. Okay, that's going to work out because I know that 2 can go to the power of something to give me 2. So log to the 2 of 2 will work out, no error there. Likewise, 2 to the power of something can give me 4. So no problems there, okay? So 2 to the power of 1 would have, 2 to the power of 1 would have given me 2, and 2 to the power of 2 would have given me 4. So that actually works out fine. Okay, over here, if I try and sub that in, okay, I would get log with a base 2 of minus 2 minus 2. Now, is, okay, plus, I'm just going to finish, log with a base 2 of minus 2 is equal to 3. Okay, now, is this possible? Can 2 to the power of something give me minus 4? 2 to the power of what could give me a minus? How many times do you need to multiply a plus together to get a minus? It's not possible. Okay, a plus by a plus is a plus. By a plus again is another plus. By another plus is a plus, and so on. So I will never be able to put a power on a 2 to get me a minus 4. So this one is not going to work out. Okay, so over here, this x equals minus 2, I'm going to write beside it that it is not valid. And I'm going to put a box around my x is equal to 4. Okay. So let's quickly have a look then at this exam question. Okay, this is a really nice exam question. It says write 1 over 81 in the form 3 to the power of or. Okay, really nice exam question because there's no variables in it. So you can actually, when you figured out how to write this as a power of 3 to the power of or, you can literally check, is 1 over 81 in your calculator the same as whatever your answer is, 3 to the power of what? Okay, a few different ways to do this. I could do 1 over 3 to the power of what? Okay, so if I can rewrite 81 as 3 to the power of something, okay, then I can figure out what it is. So 3 to the power of what is 81? Well, it's 9 by 9. Okay, so that's 3 squared by 3 squared. So 3 to the power of 4. Okay, so it doesn't ask me for 3 on the bottom of a fraction with a power. It wants it up here. So the only thing I would need to do there is use my indice rule. That if I have, let me see, 1 over a to the power of q, that is the same as a to the power of minus q. Okay, so that full thing is going to be 3 to the power of minus 4 is equal to 3 to the power of or. Okay, it didn't ask what or was, it wanted my answer in this form. Okay, so 3 to the power of minus 4 is my final answer. Okay, that's one way of doing it. Another way of doing it is using our logs, just because we're getting used to them. Okay, so 1 over 81 is equal to 3 to the power of something, so we can use or if we want, and we can use our log rule. So a to the power of x is equal to y if and only if log with a base a of y is equal to x. Okay, so rearrange here. Okay, I'm trying to find x. I'm trying to find what was in the power. Okay, so I have my thing that it's equal to is 1 over 81. A is going to be 3. Okay, and I can figure out x is or I can just leave it as x. Okay, so if I sub that in to this log rule, I will get that log with a base 3 of 1 over 81 is equal to x or is equal to or. Okay, so basically 3 to the power of what is 1 over 81, which is what the question asked. 3 to the power of what is 1 over 81. Put it into your calculator and we get minus 4 is equal to or. Okay, again, they didn't ask you for or. They want you to write 3 to the power of or. Okay, so don't forget that the question isn't finished until we write in that it's 3 to the power of minus 4. Okay, part C, another nice one, just getting used to using our log rules. Okay, the first 2 log rules there in particular, so you can see them there. The following is an expression in x where x is greater than 0. X being greater than 0 is just important here because a positive number will have to, no matter what its power is, will have to be positive. So a positive number multiplied by itself loads of times over, it doesn't matter how many, will always be greater than 0. So it's just kind of confirming that this is always true. Okay, write this expression in the form p log 10 kx. Okay, so we know how to merge those logs together using these log rules. Okay, so here I have 2 logs adding and then we see that they multiply. So straight away I can write the first 2 terms together as the x times the 18. Okay, so I can write it as log with a base 100. Now they had to have the same base for me to do that. Okay, so it was base a and base a. So log with a base of 100 of 18 times x, so 18x. Okay, I could have in that same line also looked at the fact that I'm minusing with the same base. Okay, or I can just carry that down and then look at it in the next line. Okay, a minus with the same base means that it becomes a fraction. So it's going to be equal to log with a base 100 of 18x over 3. So I should have made that bracket bigger. 18x over 3. Okay, now I'm really close to my answer because I have it all merged in. Okay, let's keep going. Can I simplify that? Yes. Okay, I know 18x over 3 is just 6x. So I have log with a base 100 of 6x. Okay, now if I start looking at getting it into this form, because I have it simplified down, okay, they have a completely different base here. They have base 10. I have base 100. So I'm going to need to use my change of base rule, okay, from over here in my log tables. Okay, so if I use that rule, it means that I can rewrite this. I can rewrite this with a log base 10. Okay, but I would be writing it as a fraction, so log base 10. Okay, and then the bigger number from the original log goes on the top, so the 6x. And then the smaller number from the original log, the original base, is on the bottom of the fraction there, so 100. Okay, so if I look at simplifying this down, okay, can't really simplify that top line there, so that's just going to stay as log with a base 10 of 6x. Okay, so I couldn't really simplify it because there's a variable in there, whereas this bottom line I can do 10 to the power of what is 100. Okay, if it wasn't a really obvious answer, I could put it into my calculator, but 10 to the power of 2 is 100, so I can fill that in. Okay, now this is almost correct, except for the fact that they don't want it written as a fraction. They want it with a number in front of the log. Okay, other than that, I have log with a base 10. I have a number in front of an x. Okay, so all this is the correct form, except for the fact that it's a fraction instead of having a coefficient in front. So how could I write the 2 that's dividing as a coefficient in front instead? Well, I can rewrite it as a half. Okay, a half log 10, base 10 of 6x. Okay, double check that matches the form that they said. So is p allowed to be a fraction? Yes. Okay, it was a real number. And likewise 6 is also a real number. Okay, so that's it done. If they didn't ask for it to show a base 10 and there was nothing written there where the 10 is, okay, that's our invisible number. So 10, anything with the log base 10 is the same as just that log without a base being written. Okay, so that's that question finished, but just so that I can kind of expand on a little bit. Okay, let's say we had this log base 10 of 100. Okay, if you actually type into your calculator, there's a separate button. So log base 10 of 100. Okay, that is the same as log of 100. Okay, so if there is no base shown, that's automatically actually a base 10. So 10 is our invisible base if ever we come across a situation where there's no base shown. Okay, so when there's no base shown, the invisible base is 10. Okay. So that one we just came across in the question, but it's actually true with anything. So log with a base 10 of anything. Okay, so type in some random number into your calculator, but just remember what it is. So something like, I don't know, 98 instead. Okay, but of anything is the same as just the log of that thing. Okay, So it has to be a 10 there. If there's no base shown, it's a 10 there that they actually have. That's the invisible base. Okay.